So in this problem, we were given that our solenoid has 2,000 turns, a length of 15 centimeters, a current of 0.2 sine omega t, and omega was given as 120 pi, and our radius is 3 centimeters or 0.03 meters. Now, to find the inductance of our solenoid, we have an equation right here that's mu naught times n squared times a all over L, which is the length. So we took our given numbers and we just plugged them in, and we got the inductance of our solenoid to be 0.095 henries.
So part B of our question was to find the max voltage across the solenoid. And then here we have the equation for the magnetic field in a solenoid. Mu naught times the number of turns divided by the length times the current, which is just plug and chug situation for this line. So we got that equal to this, and then we have the magnetic flux equation. Magnetic field times the area times the cosine of the angle, and then once again another plug and chug, and then we get this, and then that equals 7.2 volts.
So to solve part B, we actually had a little trouble at the beginning because when I wrote down the omega, I accidentally left out the pi. But we did find out that you can calculate it using many different ways. The way we used was negative n d phi b dt, which was actually a little more lengthy than we needed it to be, because we had to solve for the magnetic field of the solenoid first. If we used the negative L di dt, because we had solved for L in part A, we could have just taken the derivative of current and multiplied it by our solved inductance and had the answer. And we could have also used these two ways, negating the sine part and just using the max current and the impedance in this case here, and impedance here with just the inductor and capacitor.